This is the key to worksheet on rational expressions number 7, and this is the one where you had complex fractions rather, and you had to use either method 1 or method 2. Now there was no method that was stated, so you could have chosen either method to use. It is hopeful though that you are able to do both methods because both methods are important. You need to know both methods. So for the most part, I am going to do each of these problems using both methods, just in case you did one method over the other. Okay, so let's look at number 1. So number 1, we have this complex fraction. And so remember, a complex fraction is where if you look at the numerator and if you look at the numerator has at least one fraction in it. And it could be in the denominator as well. It doesn't have to be in both, but at least in one, either the numerator or the denominator, you have at least one fraction. And in both of these, you see you have this rational expression, 42 over y, and you have 6 over 7. Okay? And so even if you want to think about it, you can even think of y as y over 1 and 49 as 49 over 1. All right, so let's go ahead and write this problem down, and then we're going to look at method 1. So here's the first one will be method 1. So we have 49 plus 42 divided by y. And we have y plus 6 divided by 7. Okay? All right, so this is going to be method 1. So according to method 1, okay, method 1. So method 1 is where you rewrite the numerator with the LCD of the denominators. And then you rewrite the denominator with the LCD of the denominator. So basically, you're going to find the LCD of the numerator and then write equivalent fractions. You're going to find the LCD of the denominator and write equivalent fractions. And then you're going to go from there. Okay? So basically, what I would do at first is rewrite 49 as 49 divided by 1, and then plus 42 divided by y. Okay? And then so that numerator, and then in the denominator you have y divided by 1 plus 6 divided by 7. All right, so let's go off to the side and kind of look at the numerator. So in the numerator, I have this. I have 49 divided by 1 plus 42 divided by y. So what's the least common denominator of 1 and y? All right, well, y, right? And so I'm going to write two fractions with that denominator as y. So 49 is equivalent to what fraction with y as a denominator? And notice that I have 1 here. Remember, I want a y, so I need to write an equivalent fraction. And so basically what you did was you said, I'm going to write it on this side. So what you said, well, I'm going to multiply the denominator by y. But remember, what you do to the denominator, you have to do to the numerator. And so then I get y times 49, which is 49y. And it kind of makes sense because if you reduce the y's, you get 49 back. All right? And now notice that these denominators are the same, so that means the numerators have to be the same. And so remember, every rational expression is equivalent to itself. And so therefore, for the numerator, we have this now. So I'm going to rewrite the numerator as this. So I have, oh, and by the way, so now I can write this as one. Let's go ahead and do it here. So now I can write this as one rational expression since the denominators are the same. So I get 49y plus 42 divided by y. So that's the numerator. So 49y plus 42 divided by y. Okay? All right, let's talk about the denominator. So the denominator, I have the expression y divided by 1 plus 6 divided by 7. Okay, so what's the LCD there? So the LCD of 1 and 7 is 7, right? So you're going to write two fractions with that denominator. Now y divided by 1 is equivalent to what rational expression with 7 as a denominator? All right, well, what you're going to do is you're going to say, well, I have a 1, I need a 7, so I'm going to multiply the 1 by 7, but what I do to the denominator, I do to the numerator. And so 7 times y is 7y. So y is equivalent to 7y divided by 7, because if you reduce this, the 7s, you get the y back. And then notice that 6/7 is equivalent to itself, and so therefore, and now I can write this as one rational expression with the denominator 7, and so I get 7y plus 6. So that's going to be the denominator, 7y plus 6 divided by 7. Okay? All right, now, at that point, remember what we did. So notice you have one fraction divided by one fraction. And so now you're going to change the division to multiplication. So this becomes 49y plus 42 divided by y times the reciprocal of the denominator. So that's 7 divided by 7y plus 6. And now that brings us back to what we did when we multiplied rational expressions. And so remember, to multiply rational expressions, you first of all need to factor your numerators and factor your denominators, and then reduce. So notice in the numerator, it looks like I can factor out a 7, right? And so when I do that, I get 7 times 7y plus 6, because 7 times 6 is 42, divided by y, times 7 divided by 7y plus 6. And then we'll reduce. So notice when I reduce, I can divide out these 7y's plus 6, and then you need to show that, though. You need to show what you're reducing. And then that's about all I can reduce. The 7, there's no factor 7 in the denominator, but 7 times 7 is 49, and so I get 49 divided by y. Okay, so that would be the answer to number 1. Now that's using method 1. Okay, now let's look at method 2. Now method 2, you'll get the same answer. All right, method 2. So method 2 is where, let me go ahead and rewrite the problem over. So this will be method 2 for number 1. And so I have 49 plus 42 divided by y, and that's being divided by y plus 6 divided by 7. Okay, what I'm going to do first is rewrite 49 and y as a fraction. So 49 divided by 1 and y divided by 1. Okay, now remember method 2 is where you found the least common denominator of all of your fractions. So you have 1, y, 1, and 7. Okay, so the least common denominator then would be, remember, first of all, you got to make sure that when you're finding the least common denominator, that your denominators are factored. In this case, though, they're all monomials, so there's really no factoring to do. So you have 1, y, 1, and 7, so the least common denominator is 7y. Now, once you found that, remember method 2, this is method 2. Remember, method 2 is where you then multiply the numerator and the denominator by the LCD. So what you did to the numerator, you do to the denominator. Okay? And because remember, you're still thinking of this as multiplying by a fraction of 1, 7y divided by 7y. All right, now you're going to distribute. Now you're going to distribute. And so when I do that, I get 49 times 7y, right? I'm leave it like that for right now, plus 42 times, 42 over y times 7y, right? Okay? Divided by y times 7y plus 6 divided by 7 times 7y. Okay? So that's what I have. All right, now let's go ahead and reduce each of these terms, and let's see what we get. So I get 49 times 7y, and I'm going to go ahead and just leave it like this for right now. Let me just go ahead and do this. 49 times 7y plus, and then over here the y's divide out, right? So that's the whole point of multiplying by the LCD, is to get these factors of 1 down in the denominator. So that's 42 times 7 divided by, and then here I'm just going to go ahead and say 7y squared. So I don't want to multiply this out yet because I see a 7 and I see a 7 here. So I want to see what's going to happen at that point. Here I can divide out the 7's, and so you get plus 6y, right? Okay, now let's see what we get. So I know that in the numerator, and remember you have this rational expression, so you want to factor and then reduce if you can. So I know that I can factor out a 7, and if I look at the 49 and the 42, I can factor out another 7, right? And so if you did multiply it out, which probably many of you did, you would have said 49 times 7 is let's see, 49 times 7 is 343y plus, and then 42 times 7 is 294, right? Divided by 7y squared plus 6y, okay? Okay, so at this point, you want to factor your numerator. Now these numbers are not that easy to deal with, but remember, always look for perfect squares. So you always want to try the largest. So now besides 1, the next largest perfect square is 4. Now you know 4 will not go into this number here because the last digit is odd, right? And so let's try 9. 343 divided by 9. And notice 9 is not going to work, so I'm not going to even worry about you doing this one. So, and I'm using the 343 because I see it first. Then let's see, the next one after 9 is 16, right? So again, it's not going to work because of that last digit being 3. But if you want to go ahead and try, you can. 343 divided by 16. See, you don't get a remainder 0. You get a decimal, so you know you can have a remainder other than 0. So the next one's 25, and obviously that's not going to work because the last digit's 3. And the next one's 49, so let's try 343 divided by 49, and there you go. And 49 is the largest because there's a 7. Now see if 49 will go into 294. 294 divided by 49, yep, it does. So the GCF of the numerator then is 49 times, what was that, 7y plus 6. And then the denominator, I can factor out a y, and so I get y times 7y plus 6. And then notice these divide out, and the answer is 49 divided by 7. And that's the same thing you had, I'm sorry, not 7y, excuse me, 49 divided by y. And that's the same thing you had here. Okay. Now notice it may have been, for some of you, it may have been easier to do method 1. And then for others, it may have been easier to use method 2. The only issue would have been around this little area here, because then you would have to figure out, well, what is the GCF? And that's why I hesitated to multiply this out at the beginning, because I knew that at some point I would have to find the GCF. And I knew that it was going to be GCF because this has a 7. This has a factor of 7, so I can factor out a 7. But there's also another factor of 7 because 7 goes into 49 and 7 goes into 42. So there's this factor of 7, and then there's a factor of 7 in both of these. So 7 times 7 is 49. Okay? All right, so use some of those ideas to help you. All right, so that was number 1. Now, I did number 1 both methods. I don't know if I have time to do all of them both methods. We'll see. Number 2. So number 2, we have 2 minus 49 divided by x divided by 1 minus 49 divided by x squared. Okay, so let's do method 1. So method 1 is where you just looked at the numerator, and notice I'm writing 2 as 2 over 1, and finding and writing this as one fraction. So I got to find the LCD here. So the LCD is x. So I'm going to write 2 fractions with x as the denominator. So I know that 1 times x will give me x, and so 2 times x is 2x. Over here, the denominator is already the same, so 49 and 49 has to go here. So every rational expression is equivalent to itself, and so therefore this becomes, now I can write this as one fraction, this becomes 2x minus 49 divided by x. And so that's going to be your numerator. So my numerator is 2x minus 49 divided by x. Now let's do the denominator. So my denominator, I have 1 divided by 1 minus 49 divided by x squared. And so notice the LCD of 1 and x squared is x squared. So I'm going to write 2 rational expressions with x squared as the least common denominator. And so notice I have 1 here. I need an x squared, so I got to multiply by x squared. But what I do to the denominator, I have to do to the numerator. So 1 times x squared is x squared. And then these denominators are the same, so that means the numerators have to be the same. And so now I can write this as one rational expression, x squared, as the denominator. So I get x squared minus 49. So that is going to be the denominator here. So x squared minus 49 divided by x. Now the next step now, remember you have a fraction divided by a fraction, so now you got to change this to multiplication problem. So you take the fraction that's in the numerator, 2x minus 49 divided by x times the reciprocal of the denominator, so that's x divided by x squared minus 49. Okay, and it looks like, and notice I can't factor this numerator here, but I can factor the denominator, but that's not going to help at all because look, that's x minus 7 times x plus 7, right? And so the only factors that divide out are these x's right here. And so then I'm going to get, really all I get is 2x minus 49 divided by x squared minus 49. That's all I get. Now if you want to write it as this in factored form, you can. It's just not going to help you to reduce any further though. So x minus 7, x plus 7. So that was a weird one because you see, normally when you see something like this, a difference of two squares, probably one of those factors was going to reduce with something else, and it didn't. So this was a weird problem, but at least the x is divided out. All right. So that was method 1. Now method 2 is this approach now. So method 2 is where I'm going to go ahead and rewrite it as 2 over 1 minus 49 divided by x, and that's being divided by 1 divided by 1 minus 49 divided by x squared. So method 2 is where you found the LCD of all of your denominators in every fraction in the numerator and the denominator. So so remember, these are all monomial factors. So every factor you see, it has to be part of the LCD. So I see an x, right? Okay, and so I have to use it. 1's a factor of everything. I see an x squared. I have 1. I need how many? 2. So I got to put an x squared here. Okay, so that's your LCD. So now what you're going to do is you're going to take this LCD and you're going to multiply both numerator and denominator by the least common denominator. And then you're going to distribute. And so when I distribute, I get 2 times x squared minus 49 divided by x times x squared. So every term, remember, is being multiplied by your LCD. So that's what you see in here. This term times x squared, this term times x squared. Divided by 1 times x squared, distribute, and then minus 49 divided by x squared times x squared. Okay? And so let's go ahead and reduce. So notice that the whole purpose of multiplying by the LCD is to get these denominators to be 1s. And I can because look, x and x is 1, x and x squared is just one factor of x. Over here, both these x squares divide out. And so basically what you have then is 2x squared minus 49x divided by x squared minus 49. And then notice, let's see, am I missing anything? Because in the other one I got, nope, I think, no, I'm good. No, let's think about this. All right, let me make sure I did this right. So x, I got 49x. All right, so I see what happened. So look, guys, right here, remember this right here? Where we had that x squared, what did I put? X. I should have put what? X squared. So go back here, put x squared. So that means that this right here is x squared, right? So that means that when this factor of x divides itself, then I'm only left with one factor of x here, okay? And so this right here becomes this times this, like this, all right? And then that's where you have that extra factor of x right there, okay? So when I do this, notice when I do this, I'm going to factor out an x, and I'm going to get x times 2x minus 49 divided by x minus 7 times x plus 7. But again, nothing else reduces. So there's not much you can do with this problem. So I bet that when I gave y'all this problem, I messed up with some part around here. Okay, but it is what it is. But that's the answer you would have gotten in either way, this one or this one. Just be careful here, because I did make a mistake when I transferred it from here to here. I put just x instead of x squared. So we gotta go back and fix this. So it's easy to make a mistake in some of these. So just be careful. All right. So that was number 2. Let's look at number 3. Okay. So this is method 1 that we're going to use. Right. So this is number 3. We're going to use method 1. So remember, method 1 is where you take the numerator and you write it as one fraction. Okay, so here's my numerator. 2 divided by x plus 8 plus 6 divided by x plus 4. Okay, and then you find the LCD. So if you notice, these two denominators are already factored. Well, they can't be factored any further. So the LCD is going to be x plus 8 times x plus 4. So I'm going to write two fractions with that denominator. So I'm going to get x plus 8, x plus 4. X plus 8, x plus 4. Okay? And now I'm going to write equivalent fractions. So if you look at this rational expression, I want to write an equivalent fraction that has this denominator, though. I have the x plus 8 factor. Which factor am I missing? The x plus 4. So I got to multiply this by x plus 4, but what I do to the denominator, I do to the numerator. So that means that my numerator here is going to be 2 times x plus 4. Make sure you put parentheses around x plus 4, though. Over here, what factor is missing? I have x plus 4. I want to write an equivalent fraction that has these two factors. So I have the x plus 4 factor. I'm missing the x plus 8. So I'm multiply x plus 4 by x plus 8. But what I do to the denominator, I have to do to the numerator. So my numerator is going to be 6 times x plus 8. All right, and then before I write as one fraction, because now the denominators are the same, let's go ahead and distribute. Get rid of the parentheses. So I get 2x plus 8, 2 times 4 is 8, divided by the LCD, plus, and then do the same thing in the numerator here, distribute the 6, that's going to be 6x plus 48, divided by the LCD. And then now I can write this as one rational expression. Now addition is the easy kind. If this was subtraction, remember you have to put that in parentheses. That was subtraction. But that's the easy kind because it's addition. So I'm going to write this as one rational expression, x plus 8 times x plus 4 is the denominator. Now let's combine like terms in the numerator. So remember the whole point of multiplying the numerators out was to get these as terms so you can combine like terms. Always leave the denominator in factored form. So 2x plus 6x is 8x. And then 8 plus 48 looks like that's going to be what, 56? Okay? Now, let's see. It looks like I can factor out an 8, right? So now we're going to reduce. I can factor out an 8 from the numerator. So I get 8 times x plus 7, right? Okay? Divided by x plus 8 times x plus 4. All right, so did that help me in terms of factoring? Can I reduce anything? No, so that's your answer right there. So x times x plus 7. Oops, sorry. Okay, so that's your answer for this, right? So that is this, okay? That is this. But if you could reduce any further, you would, all right? But that's going to go here. All right, so don't be careful that that's not your final answer for this problem because that's just the numerator. All right, so that's going to be in the numerator, 8 times x plus 7 divided by x plus 8 times x plus 4. But that's being divided by this denominator, x plus 7 divided by x plus 8. Now remember, I'm not going to, so remember the whole point of rewriting this here was to get that one fraction. Because remember, in using method 1, you got to write this as one fraction. This is already one fraction, so there's nothing to do in terms of this right here. So this is going to stay here. Now the next step, remember, is to change this to multiplication problem. So this becomes the numerator, which is 8 times x plus 7, divided by x plus 8 times x plus 4, give me times the reciprocal here, so that's x plus 8 divided by x plus 7. Now remember, at that point, that's where you would factor your numerators and factor your denominators, but we already did that here. So remember when we did that here? Okay, but you would double check at this point as well. And now notice I can divide out some common factors. The x plus 7's divide out, the x plus 8's divide out. And so all you have in the numerator is 8 times 1 times 1, which is 8. And in the denominator, you have 1 times x plus 4 times 1, which is x plus 4. And so your answer is 8 divided by x plus 4. So that's the answer to number 3. 8 divided by x plus 4. Okay, so that was using method 1. If you had used method 2, okay, method 2, let me go ahead and rewrite the problem. So here's the problem, and we had 2 divided by x plus 8 plus 6 divided by x plus 4 divided by x plus 7 divided by x plus 8. All right. Now, when doing method 2, first thing you got to make sure is that all your denominators are factored, and there's nothing else I can do with x plus 8, x plus 4, x plus 8. All right. So then the next step, remember, is to find the least common denominator of all of these. That's the next step. So remember, in finding the least common denominator, every factor you see has to be part of your LCD. So I see an x plus 8, I see an x plus 4, and I see another x plus 8, but I already have it. You only list it once. Okay, that's going to give you the least. If you list it again, that's going to be a common one, and then you'll make things more difficult for you. So once you find the LCD, remember the next step. I'm going to go ahead and rewrite that here. I'm going to rewrite the same problem. 2 divided by x plus 8 plus 6 divided by x plus 4 divided by x plus 7 divided by x plus 8. So then what you're going to do is you're going to take the numerator and you're going to take the denominator. And notice I put the numerator in parentheses because there's more than one fraction. Here there's only one fraction, so I'm not going to put that in parentheses. But basically, the numerator and the denominator will be multiplied by the LCD. So x plus 8 times x plus 4. X plus 8 times x plus 4. Okay? And now what you're going to do is you're going to distribute this now. And remember the whole point, just remember the whole point of multiplying by the LCD is to get these factors right here to be 1s. These denominators to be 1, factors of 1s. Remember those that had circled? I want those to be factors of 1s. Okay, so when I distribute, I get, I don't know if I'm going to have enough room here, but I'm going to get 2 divided by x plus 8 times the LCD. Okay, plus 6 divided by x plus 4 times the LCD. Divided by, and then let's go ahead, I'm going to go ahead and rewrite it. So it'll be x plus 7 divided by x plus 8 times x plus 8 times x plus 4. Okay, now at that point, the next step is to divide out any common factor. So if you look at that first set of products here, I can divide out these x plus 8s. And if I look at the x plus 4s, I can divide those out, right? And then the x plus 8 here, okay? And so basically what I have is this now. In the numerator, I have 2 times 1 times x plus 4, so that's 2 times x plus 4, just like this, plus 6 times x plus 8, just like that. In the denominator, I have x plus 7 times 1 times x plus 4. So I base, and remember, x plus 7 is in parentheses, though. Okay? And now remember, you've written this as one rational expression, but you got to reduce if you can. So what you got to do first, though, is get rid of these parentheses, then combine like terms. And when I say parentheses, I mean I'm talking about them in the numerator, because remember, you want to factor the numerator, factor the denominator. The denominator is already in factored form. So you got to distribute first. And so when I distribute, I get 2x plus 8 plus 6x plus, and then 6 times 8 is 48, divided by x plus 7 times x plus 4. And then when I combine like terms, I get 2x plus 6x is 8x. And then 8 plus 48 is 56 divided by x plus 7 times x plus 4. Okay? And then at this point, you factor the numerator. So I can factor out an 8, and when I factor out an 8, I get 8 times x plus 7 divided by x plus 7 times x plus 4. And then I can divide out these x plus 7s, and so the answer is 8 divided by x plus 4. Okay? So no matter which method you use, you get the same answer. All right. Now, some of these problems they can get pretty involved, right? They can get pretty involved depending on the method you use, and even both methods can get pretty involved with some of these problems. All right, so that was number 3. All right, let's look at number 4. So number 4, I have this problem: 1 plus 3 divided by x minus 10 divided by x squared. And I have in the denominator 1 minus 4 divided by x minus 45 divided by x squared. Okay, so that's the problem we have. So if I use method 1 first, okay, method 1. So method 1, remember, means that you got to write the numerator as one fraction. You got to write the denominator as one fraction. So there's some work we got to do here. So let's talk about the numerator first. And I'm going to write 1 as 1 divided by 1. So 1 divided by 1 plus 3 divided by x plus 10 divided by x squared. So what's the least common denominator of all of these? Because these are all monomial factors. So it's x squared, right? X squared. So I have one factor of x here. I don't have any here. And I have 2 here. So I need 2 of them. So now I'm going to write 3 fractions with that denominator. That's what I've got to do next, right? 3 fractions with that denominator. And that's where you're going to write equivalent fractions. So 1 is the same as what fraction with x squared? Well, remember, that's a 1, right? So anything divided by itself is x squared. So that means that the numerator here has to be x squared. And that's how you got it. Look, this is how you get it. So you said 1 times what's x squared? Well, x squared. But what I do to the denominator, I have to do to the numerator. And so that's where you see x squared times 1 is x squared. Over here I have x. I want x squared. So what do I need to multiply this factor of x by? Just x, because x times x is x squared. But what I do to the denominator, I do to the numerator. So I get 3x. Okay? All right. Over here, I already have an x squared. So every rational expression is equivalent to itself. So this is going to be a 10. And now I can write this as one rational expression. So this becomes, with the denominator x squared, so this becomes x squared plus 3x plus 10. All right, and let's go ahead and factor this right now. So if I factor this, it looks like I'm going to get x plus, actually it cannot be factored, right? So that's it. So this cannot be factored. Okay. Oops, I'm sorry. That's a minus right here. Okay, so subtraction. See, you can easily mess up, right? And now it can be factored. So when I factor this, that's going to be x plus 5 times x minus 2. All right, so be careful. You can easily mess up as you go along. So always come back, if you have time, always come back and make sure that you wrote all your steps correct. So that's going to be the numerator, so that's going to be the numerator here. So this is this. So remember, at some point you're going to factor, so let's just go ahead and do it here. So I get x plus 5 times x minus 2 divided by x squared. The denominator, let's talk about that. So the denominator, you have 1 divided by 1 minus 4 divided by x minus 45 divided by x squared. And so the LCD, again, is x squared, right? And so I'm going to write 3 fractions with x squared as the denominator. Make sure I wrote this one correct this time. I did. And now you're going to write equivalent fractions. So I have a denominator 1 here. I want it to be an x squared. So I got to multiply by x squared. But what I do to the denominator, I do to the numerator. And so this is going to be x squared right here. And it makes sense because x squared divided by x squared is 1. Here, I've got to multiply x by x to get x squared, but what I do to the denominator, I do to the numerator. So this becomes 4x. And over here, this is already an x squared, so that means every rational expression is equivalent to itself, so the numerator has to also be 45. And so now I can write this as one rational expression. And so when I do that, I'm going to get denominator x squared. I'm going to get x squared minus 4x minus 45. 45. All right, now let's see if I can factor this. So in the numerator, let's go ahead and factor here instead of doing it here. So I'm going to get x minus 9, x plus 5, okay, divided by x squared. So that goes here now, because remember this right here, we just found, that's this. So that's going to go here now. So x minus 9, x plus 5, divided by x squared. Okay, now we're almost done with method 1. So now I have a fraction divided by a fraction. So I'm going to change this division to multiplication. So this becomes the numerator, x plus 5, x minus 2, divided by x squared, times the reciprocal of the denominator, x squared, divided by x minus 9, x plus 5. Okay? And now you're going to divide out any common factors. So I have an x plus 5 I can divide out, right? Right here. I see that. And then these x squareds can divide out. And that's about it. So you get 1 times x minus 2 times 1 is x minus 2. And the denominator, you have 1 times x minus 9 times 1 is x minus 9. So there's the answer. So number 4, your expression simplifies to x minus 2 divided by x minus 9. Okay? Now let's do method 2 with this. So method 2 would say this. So method 2, okay, same problem. So we have, so this would be method 2. So we have 1 divided by 1 plus 3 divided by x minus 10 divided by x squared divided by 1 divided by 1 minus 4 divided by x minus 45 divided by x squared. So remember, method 2 is where you look at all of your denominators, and those are all factored form. Those are all monomial factors, I should say. And so your least common denominator then, looks like it's going to be what, x squared? All right, so once you find it, I'm going to go ahead and rewrite this over. So I have 1 divided by 1 plus 3 divided by x minus 10 divided by x squared. And then that's being divided by 1 divided by 1 minus 4 divided by x minus 45 divided by x squared. So once you find the LCD, you're going to take the numerator and the denominator, and you're going to multiply by x squared. Okay? And now you're going to distribute. Just like this. Okay, so here's what we get. We get 1 times x squared. So that's just x squared. Plus 3 divided by x times x squared. So remember when doing method 2, every term is being multiplied by x squared, and that's what you see. And then the third term, 10 divided by x squared, is also being multiplied by x squared. Divided by, and the same thing in the denominator. 1 times x squared is x squared, minus 4 divided by x times x squared, minus 10 divided by x squared times x squared. I'm sorry, 45 divided by x squared times x squared. Okay? And now we're going to reduce. So remember the whole point, so all those denominators I have circled, at this step, this is where all of these have to be factors of 1. Okay? And then they will, because look, x divided by x is 1, x into x squared is just one factor of x. Over here, both these x squareds divide out. Over here, same thing, one factor of x. So x divided by x is 1, x into 2 factors leaves me with 1 factor left. And then these factors of, that's supposed to be x squared right here. And so these factors of x squareds divide out. And so now what we have is this. We have x squared plus 3 times x is 3x. And then minus 10 times 1 is 10. Divided by x squared minus 4x minus, and then that's 45, because 45 times 1 is 45. And then at this point, remember, that's where you have this rational expression. You got to simplify. So you got to factor. So when I factor the numerator, I'm going to get x x plus 5, x minus 2. And then the denominator, that's going to be x minus 9, x plus 5. And then you reduce. So the x plus 5's divide out. And make sure you put ones in their place. You got to show that. And so the answer will give you x minus 2, because 1 times x minus 2 is x minus 2. And then x minus 9 times 1 is x minus 9. So you see you get the same answer. So regardless of which method you use, so either method 1 or method 2. Okay? All right, and then finally number 5. So number 5, we have x squared minus 2x minus 63 divided by x squared minus x minus 56. And that fraction is being divided by this one, x squared plus 10x plus 24 divided by x squared minus 4x minus 32. Now, when you got this one, when you looked at this one, I'm hoping that all of you figured out that method 1 would be the easiest. Method 1 is the easiest here. And the reason is because notice the numerator is one fraction, the denominator is one fraction. So method 1's the easiest. You just got to factor first, so let's go ahead and do that. So let's go ahead and factor first. So in the numerator, this numerator here, it looks like, let's see, I'm going to need more room, so let me just do that here. So x squared minus 2x minus 63, that's going to be x, and then what, 9 and 7? So, and then minus 9 plus 7, okay? And that works, all right? The denominator here, that's going to be, when I factor, that's going to be x, and I need 56. So let's see, that's going to be, let's see, 56. Use your calculator if you need to. 56 and 8, I'm sorry, 7 and 8, all right? So 7 and 8, so be 7, 8, and then the last sign's negative, so it means these signs are different, and I need the larger of the outer and inner to be negative. So that means this has to be negative and this has to be positive, okay? Divided by, and always check, because the outer is negative 8x, the inner is 7x, and I do get negative 1x, and then 7 times negative 8 is a negative 56. The denominator, in the denominator, for the numerator part of the denominator, we get, let's see, we get x plus 6, x plus 4, divided by, and then the denominator of the denominator part, we get, let's see, x minus 8, x plus 4. Okay? So now I'm going to write this as one, I'm going to change this to a multiplication problem. So this becomes the numerator times the reciprocal of the denominator. So I get x minus 9 times x plus 7 divided by x plus 7 times x minus 8 times the reciprocal of this. So it'll be x minus 8, x plus 4 divided by x plus 6, x plus 4. And now let's reduce. So remember, everything's in factor form now. So let's reduce. I have a factor of x minus 9. I don't have any down here. I have a factor of x plus 7. I have one right here, so those divide out. Make sure you show that. I have a factor of x minus 8. Those divide out. Show it. I have a factor of x plus 4. Those divide out. Show it. And so it looks like the only factors left beside factors of 1 is x minus 9. And so I get x minus 9 times 1 times 1 times 1 is x minus 9. And then 1 times x plus 6 times 1 is x plus 6. And so there's the answer. So x minus 9 divided by x plus 6. So x minus 9 divided by x plus 6. But method 1 was the easiest because these the fraction in the numerator, there was just one fraction, and then the denominator, there's just one fraction. So once you factored all parts, then you just change the multiplication problem, and then that's what you see here. And then you reduce. Now, if you had used method 2, let's talk about method 2 here. So if you had used method 2, okay, method 2, let me go ahead and write the problem over. So here's the problem. We had we had x squared minus 2x minus 63 divided by x squared minus x minus 56. And that's being divided by x squared plus 10x plus 24 divided by x squared minus 4x minus 32. Okay, so remember, when using method 2, you have to find the least common denominator of all of these denominators. Okay? The problem is that these are trinomials, so we got to factor first. So at this point, that's where I would go ahead and factor the numerator also. So remember, when we factor the numerator, we get x minus 9, x plus 7 divided by x plus 7, x minus 8, and that's being divided by x plus 6 times x plus 4, so that's this right here, divided by, and that's going to be this one, divided by x minus 8, x plus 4. So remember, when using method 2, you got to look at the factors in this denominator and look at the factors in this denominator and find the LCD. So the LCD of all those factors I have circled, I have an x plus 7, I need an x plus 7, right? I have an x minus 8, I need an x minus 8. Now let's go to the next one. I have an x minus 8, I already have it. I have an x plus 4, I need one. Okay, so I got to put another factor of x plus 4 here. So those are my 3 factors in my LCD. Once you find your LCD, remember the next step, let me go ahead and rewrite this over. X minus 9, x plus 7, divided by x plus 7, x minus 8. You see how method 1 was easier? So this looks like it's getting complicated. Divided by x plus 6 times x plus 4, divided by x minus 8, x plus 4. So all I did was I rewrote this problem. Now I'm going to multiply the numerator and the denominator, numerator and the denominator. Now I'm not going to put parentheses here because that's just one fraction. So it's going to be times the product of these 3 factors. So x plus 7, x minus 8, x plus 4, times x plus 7, x minus 8, x plus 4. And now I'm going to reduce. So notice remember the whole point, these denominators I have circled, all of this but end up being 1. Okay, that's the whole point of multiplying by the LCD. And they do, because watch, x plus 7 into x plus 7 is 1. X minus 8 into x minus 8 is 1. See that? And then all you have left, see those are factors 1. So all you have left in the numerator then would be x minus 9, x plus 7 times x plus 4. X minus 9, x plus 7, x plus 4. The denominator, remember these have to end up being 1s, and they do, because look, x minus 8 into x minus 8. X plus 4, x plus 4. And so now you have these 3 factors. So you have x plus 6, x plus 4, x plus 7. And at that point is where you're going to reduce. So everything's already factored. So now you're going to reduce. So it looks like the x minus 9s, I cannot, there's no factor x minus 9 in the numerator. There's an x plus 7, I can divide those out. There's an x plus 4, I can divide those out. And so your answer is x minus 9 times 1 is x minus 9. And then x plus 6 times 1 is x plus 6. And so you see, you get the same thing. All right, so that's method 2, and this was method 1. Okay, so method 1 was easier, and only because these were already listed as 1 fractions. All you had to do was factor, change the multiplication, and then reduce. All right, so that is the key. That is the key to worksheet 7. And the only reason why it took long was because I did each problem using both methods. All right, but that is a key to worksheet 7, where we had to simplify complex fractions. All right, so just go back over it. Make sure you know how to do both methods. It is important that you know both. You're not going to be told to use one method over another in this class. Now next semester you may. depending on what y'all do in the next class. But in here, you can choose whatever method you want. All right, that's the end of this lesson.